Good morning. Welcome everyone to the MSU Extension Field Crops Virtual Breakfast. My name is Eric Anderson. I'm a field crops educator down in the southwest part of the state. I'll be moderating the session for this morning. I'm glad you're all able to join us. This morning we're going to be talking about irrigation, which is definitely a topic of interest for us down in the southwest on our lighter textured soils. And we'll also get a weather update from Jeff Andreessen. So again, today we're going to be talking about irrigation topics, strategies for using our irrigation water as efficiently as possible. And here to talk about that is Dr. Younsuk Dong. Here's our irrigation specialist on campus here. So Younsuk, go ahead and take it away.
All right, well, thanks, Eric. So good morning, everyone. So this morning I'm going to talk about, what are the information, the strategy we should know to improve water use efficiencies. So I'm gonna dive into the soil. So we need to know the soil type of our field. The soil type is key parameter that determines the water holding capacity. So in general, the finer texture of your field, the texture of soil can hold much more water than sandy soil. So it's very important to know what type of soil you have on your field, and from that we can estimate how much water the soil can hold in that field. So what are the methods to measure the soil type? The one method is taking actual soil samples. So simply take take a shovel to the field and grab soil, or you can use soil probes to take soil samples and send to the lab and get the percentage of clay, silt, and sand. And based on the information, you can determine what type of soil that you have on your field. Another method to look at soil type of your field is using the USDA web soil survey. So later I'm gonna copy this link of the website in the chat, so you can check out the website. And maybe next couple of slides, I'm gonna show you briefly how you use this web soil survey website. So when you get to this website, just click the Start WSS in the middle. Start Web Soil Survey Program. Once you get on the web page, and on the left box there, you can add you can type your address of your field, or you can type the GPS coordinate. And once you hit enter, then the program will direct you that specific field. After that, you can click the AOIA buttons on the top. So AOI basically means the area of interest. So once you click the button, you can select the area that you're interested in the map, and then click the soil map tab on the top, and it will show you what type of soil you have on this specific field. So in this example, it looks like in the red square on the map, majority of field has the 4B soil. So what is 4B means? So when you go on to the left, there's a table that shows what the 4B and 5B means. So 4B is the Astamo sandy loam soil. So this field has Astamo soil, and that's account for majority part of the field. If you look at the upper right corner, it says 5B, and you see the orange boundary, the line. So that little upper right corner part of the field has different soil type. And when you look at the table on the left, the 5B means the spink loamy sand. So this is one way you can go onto the USDA web soil survey website to look at what type of soil you have on your field. So based on the information, so let's say we found that our field has Astamo soil and spink soil. The USDA, the website provided what is the average water holding capacity for different depths for that specific soil. So the Linden prepared this nice table that shows what is available water holding capacity top 24-inch for Astamo soil, and what is available water holding capacity for top 36-inch forastamu soil as well. So when you look at the first the second row at the astamu, the top 24-inch forastamu soil can hold about 3.3 inch. When you look at the 36-inch depth, now you're seeing the 5.09. Compared to the spink soil, so spink soil is more loamy sand, so has less water holding capacity when it compared to astamu soil. So top 24-inch for spink soil is 2.16. Top 36-inch for spink soil is 2.64. So so using this USDA soil survey, the program, you can estimate what is the water holding capacity for top 24 or top 36 inches. So if you're going soybean, we typically consider top 24 is what you need to focus on. If you're going corn roots are going a little deeper, so we suggest to look at the top 36 inches. So we just talked about that we need to know soil type of the field because which determines the water holding capacity. Now I want to talk about the plant water use. So left figure shows the crop coefficient and the changes when as the corn grows over time. So this graph just showing the crop coefficient, and crop coefficient is basically the multiplier that you use to calculate the actual crop evapotranspiration based on reference potential evapotranspiration, which I'm going to talk about later in this presentation. But here I just want to show you how the crop coefficient changed over time. So the lower number basically means use less water. Higher number means use more water. So as you see, when the corn's young, crop coefficient is really low. So it means it doesn't use a lot of water. But as corn grows and right in the mid season, so typically at the reproductive stage, the corn use a lot of water, and then at the close to harvest season, and then crop coefficient drops to around 0.6, so it uses less water than the reproductive stage. So this is something we need to keep in mind when we think about water use for the crop. That when crop's young, doesn't use much water, but when the crop's at the reproductive stage, it demand and use a lot of water. So that's something to think about. On the right graph, it shows the percentage of the water extraction. So, well, this applies on a lot of different crops. So, as a rule of thumb, about 70% of the moisture extracted by roots is obtained in the top half of the root zone, and about 20% from the third quarter, and about 10% from the soil in the deepest quarter of the root zone. So keep in mind about 70% of the moisture is extracted by the top 50% of the root depth. The most critical time, and most critical time for what the corn needs for water and for irrigation is from VT until the R6. So VT is basically corn developed a tassel, which begins around 9 to 10 weeks from after emergence. So that's something to think about when is your emergence state, and from that we can kind of estimate when the corn will be at the VT stage. We typically recommend when corn is at the R5, the dense stage, make sure the soil moisture is greater than 50%. When the corn grain, if you see the black layer on it, black layer on the corn grain, then the other study also show that there's no benefit of putting extra irrigation after you see that black layer on the corn grain. So that's something to think about. So BT and between the VT stage and R6 are the critical time for irrigation, and that's critical time when the corn needs couldn't use the water and needs water to maximize production quality. When we look at the soybean, the overall the trends of crop coefficient is similar. So when soybean is young, you use less water. When soybean is at the reproductive stage, you use a lot of water. And at the harvest, close to harvest season, then the crop coefficient drops down to 0.2. The most critical time for soybean is during the pod development and seed fill. So basically from R3 to R6 stage, the critical time that we need to make sure we provide enough moisture to the soybean. The right table, it shows you kind of average number of days takes to each stage. So based on these numbers, we can estimate when the R3 stage will be based on your current soybean stage or based on from the emergent stage, based on the emergent state. Last year we had a field that down in Constantine has soybean, and one of area, I think it's dry land. We had a really good rainfall until I think mid of July, and then we didn't get much rainfall after mid of July, and that stressed the and we found that there's less water holding capacity on the dry land, and at that point the dry land water holding capacity went down to 40%, and that resulted in about 20 bushel per acre less than what other fields, other part of the irrigated field. So what I want to just make a point is, if you stress the water and doing this R3 to R6 stages, you may lose the yield. So just keep in mind to make sure you water, make sure carefully and between the R3 to R6 stages. So when we think about the last irrigation for soybean, make sure you maintain the moisture level greater than 50% until the field is 50% yellow. So another way to check is when one pod of soybean, if it's at the if it changed to the mature color, then that's the time that you can stop the irrigation. For wheat, so we get question about when should you stop the irrigation for the wheat. As rule of thumb is the soft dough stage. So when the wheat is reached at the soft dough, you can give the last irrigation and probably no more after soft dough stage. But if your soil has coarse texture soil, sandy soil, then it might be better. It might be good to do another application at the hard dough stages, because the sandy soil doesn't hold much more water. So we suggest to do another irrigation at the hard dough. And this year we have the site down in Constantine, the wheat field, that we are actually doing the demonstration comparing the last irrigation at soft dough with the last irrigation at the hard dough. So this is about half circle, and we divide it into 4 different sections, and we apply the irrigation. We do the last irrigation at the soft dough and hard dough. Right now, I think Monday we checked the field. Right now the stage at the milk stage. So probably very soon this wheat field will be at the soft dough stage. And just for your information, this field has Sphinx loamy sand soil pre-uniform. So it's typically a little coarse, the texture of the soil. Moving on to potato. So if you're growing potato, the critical time for watering is the tuber initiation, tuber working stages. But the potato, keep in mind, the potato are very sensitive to water. So you need to keep the moisture moisture level pretty high throughout the growing season. Another thing to keep in mind is when we considering the root depth for potato are typically shallow. So probably top 18 inches is what we consider. maybe 24 inch at most. So I talked about, hey, we need to make sure keep the moisture level greater than 50%. But how do we know our field is 50% or 70% or 40%? You can use these weather-based irrigation scheduling or the soil moisture sensor-based irrigation scheduling methods to determine that. So I'm gonna start talking about weather-based irrigation scheduling first here. We can estimate actual crop evapotranspiration based on using the number of the crop coefficient and reference potential evapotranspiration. So the crop coefficient is just basically multiplier, and that change they change as the crop grows, and so it is different from the different crops. So you have to look at the crop coefficient numbers for specific crop type that you have and specific growth stage. And the reference ET is basically it's based on the 4-inch grass covered unshaded well drained soil. So this is basically reference number. So you have to multiply the reference number times crop coefficient to get the actual crop evapotranspiration. Well, thankfully, we here at Michigan, we have MSU Enviroweather Program, has over 120 weather stations across Michigan. So we can get the reference evapotranspiration values from this website, Enviroweather website. The one thing I want to point out here is if you go on the website, go under the irrigation tool, the first one, the sign up for RPT text alert. I think I suggest to use it. I sign up for it. What it does is every morning about 5:30 in the morning, you get an email or a text message about the last 4 days of evapotranspiration and what is 7 days the future predict evapotranspiration. So this slide talks about how we use those data. So on the right top figure, the photo it's screenshot of the email I received yesterday. So this the ET evapotranspiration, the reference evapotranspiration value that I got from MSU Enviroweather at the Constantine stations. Last 4 days, when I add up last 4 days RPT, it came out 0.93 inch. And we have the soybean field down there, and it's about at the 0.5. It's about at the V1 stage. So when I look at the chart down right bottom chart, the crop coefficient is at the 0.5. So what we need to do is multiply by the last 4 days ET times 0.5, and we get the 0.46 inches. So although the reference ET shows 0.93, but actual crop water use is about 0.46. So this is one way you can use the evapotranspiration values to get the actual crop water use. So I think this is kind of good time, and we haven't got much rainfall down in Southwest Michigan since last Monday or Tuesday. And this early growing season, a lot of folks apply about half-inch application. So now is probably a good time to apply half-inch if you haven't done. So another way to use the weather-based irrigation scheduling method is you can simply download the MSU Irrigation Scheduler program. This is Microsoft Excel based program. So once you download the program, you have to type in what crops you're growing, what was the emergent state, what is soil type you have, and you can choose the closest to MSU Enviroweather station. And the cool thing about this program is once you click the button, it will download the evapotranspiration values automatically from MSU Enviroweather web network. So that will save some time. And the program also tells you what the status of moisture level on your field. So make sure you keep the moisture level between the wilting and the full water holding line, so that we can minimize water stress to the plant and make sure we don't over irrigate them. We're gonna talk about real quick on sensor-based irrigation scheduling method. So you can use the weather data to drive when to water and how much to water, or you can also use the soil sensors to make a decision. Here's some general the numbers for two different sensors. So one's for watermark, you use the soil tension. So if you have a watermark sensor and if you have loamy sand, and if you want to know the 50% depletion in water holding capacity, you can use the chart. So, for example, let's say you have loamy sand, your watermark sensor tell you is 40 kilopascal. So if you look at the table in the middle, the loamy sand 40 kilopascal means 50% depletion in water holding capacity. So that's time that maybe you want to start irrigate. But keep in mind that if your pivot takes about 3 days to apply, 3/4 inch, so then you might want to start irrigating a little bit earlier. You can use the volumetric water content sensor to do same ways to determine when to water. Well, lastly, I want to talk about I want to share the data. So we installed the sensors over down in Sturgis and Kansai, Michigan, and these sensors were in the 6, 15, 24-inch depth. Looks like last Monday, I think June 13, the night of June 13 and early June 14, we had a lot of rainfall. So both the field got about 1.5 inch, 2-inch application. That filled the whole profile. So I think we are at the good start. But as you see, we haven't got much rain since that. So so maybe it's some time. I know Jeff's gonna talk about the weather forecast, but if there's no rainfall is coming next couple of days, maybe it's good to start thinking about putting 1/2-inch applications. If you're planning on adding irrigation system to your field, please check our MSU Extension Irrigation website. It has a lot of information about what are the checklists that you need to think about when you're planning on irrigation system. So with that, here are our email address. If you have any question about the irrigation, just please contact us or check our website. All right, thank you.
All right, thanks, Younsuk. So as you can see on the screen here, for those of you who are on the computer, there are many ways to access Virtual Breakfast. One of them obviously is this morning, but we also have recordings. Those are on our field crop website, but we also have recordings available on podcast stations as well. So for those of you who have questions, please go ahead and put those in the chat box. We've only got a couple of them so far, so we've got plenty of time. The first one is for Younsuk. Younsuk, lots of farmers are improving their soils by increasing organic matter. What would be the organic matter content when the USDA, the Water Soil Survey, provides with that water holding capacity? Do you have a sense of that?
That's a great question. So I didn't see the specific organic matter content for that for different soil. So if you're based on your testing, if your field has organic matter of the field has been increased has been increased over time, but maybe I would suggest use the little higher number of the ranges, because the state give you the range of the water holding capacity. So maybe you could use a little bit higher one, but I didn't see any specific organic matter for specific soil type. But that's a good question. Yeah.
We also had a question, and Younsuk answered it in the background here, but I'll ask it for those folks who are on the phone. Someone asked, how many gallons of water equate to an inch of water per square foot or 100 square feet? And for those of you who are doing smaller scale farming, the calculation there, Younsuk put a number in, and you just need to know there's 231 cubic inches per gallon. And so whatever area you're looking to water, you can just do the math on that, get a total cubic inches, and then divide that by 231. Most folks who are doing farming, they're looking at acres. So there's just a little over 27,000, what they call an acre inch. So that's a good question for volumes. I've got a comment here from Chris Stefanzo. Asiatic garden beetles, they're pupating in southern Michigan. Chris, you want to go ahead and just talk a little bit about that?
Yeah, so the garden beetles, if you're in Ohio, the pupation is done and adults are emerging. If you're in the northern part of Ohio, if you're in southern Michigan, like Dundee, Centerville kind of area, then we're just starting to see pupation probably in another week or so. The damage will be done and stuff will be done. Western bean cutworm, I'm setting up my traps this week and next. So if you're a cutworm trapper, think about 4th of July, the day after 4th of July, set them up and start your trapping. And then there is a huge fall armyworm flight in Texas right now. It's like 6 times the normal. And this is after last year's huge armyworm flight that came very late to us. And that strain of armyworm attacked alfalfa and cover crops. This, I believe, is the corn strain. I have they don't usually get up here very early. I don't know what to think about this, but I'm on the Texas podcast link, so I'm getting this info. And we're Ohio, Michigan. We're going to start putting our traps up next week in case they do arrive. So can't say that they're going to arrive or not. That depends on Jeff's weather streams sort of bringing them and carrying them up here. But I'm just telling you that in Texas, they're experiencing something they've never experienced before. It's very dramatic numbers.
Chris, I saw my first leafhoppers yesterday and today.
Yep, they usually arrive mid to late May, and there were some events that would have carried them, and that carries the grain aphids as well, and some of the cutworm type things. So those, again, it's Jeff's fault, and we're just the recipients.
Thanks, Chris. Younsuk, we've got one more irrigation question. Do the irrigation programs adjust for cover crops via interseeding?
That's a good question. I think Lyndon's here. Lyndon, do you want to take this question?
Yeah, I can say something about it. But most of the water use is related to the amount of sunlight interception. That's the biggest driver. So if we have enough interseeding that's changing, then yes, we're probably going to use more water. I think if we're interseeding enough that we've filled the row quicker than we would otherwise, I think we need to advance the coefficient number that Younsuk was talking about. Maybe rather than 40%, we're probably at 50 or 60%. Same thing if you've got a cover crop that you haven't successfully killed from last year. If it's using up water, our coefficients are going to be a little too low. They're expecting bare ground in between the row. The good way to avoid problems is use soil moisture techniques, whether it's hand sampling or electronics. And then it's a little late, but look for crop. Let the crop tell you that you were short on water. That would be go out this afternoon at like 2 o'clock and look at the areas of the field where the soybeans are flipping their leaves to reduce their sunlight interception. They'll look real silver, or where the corn's rolled up. It's a little late to tell you that, but those things will tell you that you're using more water than what you're putting down.
So I know, Younsuk, this wasn't specifically part of your presentation today, but both you and Lyndon talked quite a bit about the number of irrigation events. You want to minimize those because you're losing a certain amount of that irrigation water with evaporation right off of the crop canopy. But at this stage, when crop is still fairly small, rooting depth is fairly shallow. Can you talk a little bit about the balance between wanting to, get a good amount of water on per event versus needing more frequent events to keep the top watered?
Yeah, so I think that typically at this stage, we recommend half-inch application, and as the crops develop over time, I think a lot of folks increase to 3/4, or maybe 1 inch, depending on the capacity and the weather condition. So the half-inch would be good suggestion at this point to wet the shallow depth of the soil moisture. And I think the one other suggestion it would be is use the scheduling tool to keep a track where your moisture level is at. So that will help make sure you have enough moisture in the soil, or you can use some soil moisture sensor to measure.
Okay, thanks. So this is maybe looking ahead a little bit. I know that our pathologist, Marty Chilvers, is going to be on later this summer talking about tar spot, but you can address it now. When will irrigation events start to increase tar spot?
Hey, Eric. So essentially, as soon as we have tar spot starting to develop, I mean, I think really the key periods here are going to be July and August, late July and August. That's where we're really going to see, tar spot begin to develop. Last year, we detected tar spot on the 1st of July after we had about 10 days of wet weather at the end of June. So I'm going to be looking for a period of wet weather, and that would be an ideal time, to start scouting, especially as that corn canopy starts to develop.
Okay, thanks, Marty. So I'm going to read this. Chris Defonso, our entomologist, just put a note in here. Someone had kind of texted her on the side, asking about the difference between fall armyworm and true armyworm. And they're different species. True armyworm comes in early, typically attacks wheat, which we're past that. So that, as you've been hearing on the virtual breakfast so far, she's been talking about the counts for armyworm. That's true armyworm. Fall typically comes very late, attacks corn and forage crops. And again, she said she's never seen fall armyworm until this last fall. So a good comment about that. They're different, true armyworm and fall armyworm.
And you need different lures. That's what's important. So if you want to trap, you got to call Great Lakes IPM, and get a different lure for that.
All right. Are there any other specialists on this morning who had some comments for us? I know our weed specialists are not on there, busily getting ready for our weeds tour, which is next week, next Wednesday. So for those of you who have never attended the weeds tour, consider attending. I know it's kind of a busy time of the year, but they always have a really good display of different projects, different spray treatments, and associated costs with those. So you can check that out. I believe that's next Wednesday. Any other specialists have anything to add this morning? And then I'll open it up. Anyone else in the audience have any other questions? Again, you can put those in the chat, or at this time, if you'd like to unmute yourself, you can ask with your microphone as well.
Eric, I'd just like to make a comment about weed control in corn. Being careful with this heat. We've had a situation up here where we had a growth regulator and we had some crop oil. So I think with the heat we had some damage, which we think it'll probably grow out. Aaron isn't here to talk a little bit more about it, but I think with the heat, with our herbicide applications, really pay attention to the label, pay attention to what additives need to go in. I think that's just really important, just to prevent any injury that we really don't need on the crop when it gets this hot and dry.
Thanks, Paul. So I did talk with Christy Sprague, one of our weed specialists, earlier this week. For those of you who do have one of the traded soybean packages, if you've got Extend, remember the label has now changed, and we do have a cutoff date of June 30th. So for those who are thinking of making an over-the-top dicamba application, that's got to be sometime just in this coming week. It looks like at least down in our area, the winds are going to be low enough. Temperatures are going to be fairly warm. And Christy did want to kind of caution people, once you get over 80 degrees, the chances of volatilization increase with dicamba. So be careful if you're going to be spraying dicamba over the top.
Question. If you don't have a well for irrigation, but you're using a pond, are there any risks? And is there a good website, or can you put an article, citation about those risks, please?
Good question. So Younsuk or Lyndon, any feedback on that?
This is Lyndon. The biggest issue with ponds is, will they recharge? If you look at the amount of acreage that you're going to cover and the size of the pond, the pond capacity often doesn't come close to doing the coverage. Let's say you've got an 80-acre field and a 1-acre pond, you'd give up 80 inches of surface or of depth every time you put 1 inch on the field. So our ponds have to recharge. That's the big issue. It's a good idea to go out in the middle of the summer with a portable temporary pump and use a traveler or something and pump that pond and see if it recharges. If it's recharging, the water will come in colder, closer to 52 degrees. But usually people will tell just by depth as you pump, if the level stays pretty close to the same or comes back up to the same level within a half day or so, then you've got a good chance. But the risk that we have is that your equipment cost is so high. If you invest in the equipment and don't have a good source, it's like not having a good heart. You're not going to have the water supply to make the use of the investment in the equipment. That's the big challenge. The paper that Younsuk referred to has a good review of that. I think it's called Checklist for Irrigation Planning. Be glad to talk to anyone about it too. Give me a call.
Thanks, Lyndon. And again, Younsuk on one of his last slides had the email contact for both Younsuk and Lyndon. So if anyone has any follow-up questions about irrigation issues in general, definitely feel free to reach out to either one of them. So there are no more questions in the chat at this point, and we're at 8 o'clock. So I want to thank everyone again for attending, and we look forward to seeing you back here next week.